8.3. Today we are solving by factoring. So the last time we were here, we looked at graphing quadratic functions as well as solve by graphing. So we got the roots by determining where the graph crossed the x-axis. Now graphing can a lot of times be a very involved process. It takes a long time for us to go through all of the steps to create the table of values, okay, just to pull out the roots. So there are other methods that perhaps don't involve as much setup and process to determine where these functions cross the x-axis, because that's ultimately what the roots are. So today we have an alternative method. We're going to be able to find the roots without having to create a graph. So in order to do this, just like solve by graphing, the function had to be equal to 0. So that means we have to get all of the terms onto the same side of the equation. Okay, we're then going to use our methods for factoring. So remember, we always start with a GCF and then we check the number of terms. So we could do grouping, we could do magic, difference of squares, okay? These are all methods for factoring. Now, once we do that, we're going to set each factor equal to 0, and we're going to solve for x. And that will give us the same result as if we created the graph and looked for where it crossed the x-axis. So our first example is 2x squared equals 14x. So very first thing, it has to be equal to 0, which means moving all of the terms to the same side. So I'm going to subtract a 14x. Okay, and then I'm going to determine my method for factoring. So it's only two terms. Okay, grouping and magic are out, and the very first thing I want to check for is a GCF. So these have a 2x in common. Okay, now remember, we're factoring, so we hang on to that GCF on the outside of the parentheses. Okay, because we need that. That's going to produce another root for us. We're going to take each of these factors and separately set them equal to the 0 that's on the other side. So we have 2x equals 0 and x minus 7 equals 0. And we're going to solve each one of those for the roots. Okay, so these are your roots. So what does that mean? If I were to graph that function, the parabola would cross the x-axis at 0 and 7. So the graph could look potentially something like that. Of course, that's just a sketch, but that is the situation that we're trying to depict here. All right, so we're going to do another one. Again, everything is on the same side. This is already set equal to 0, so I can just go in for my factoring. Okay, the first method we check is GCF. So this does have something in common. There's an 8. So I'm going to take that out and carry down equals 0. Now, just because I did one method does not mean I am done, because this is not fully factored. X squared minus 9 is a difference of squares. So if we remember, we're going to square root each of those terms, get one with the plus and one with the minus. Now my GCF gets carried down. And now each of my factors gets set equal to 0. So 8 equals 0 does not produce anything. It's not even a true statement. Okay, we still set it up to check. Now these other ones I can actually solve. Okay, I have two roots. X equals -3, x equals +3. So one of the benefits to having an alternate method to graphing, okay, not only is this quicker and more to the point, but sometimes, and we saw this with graphing, some of our methods didn't give us an exact answer. We had two estimated roots, okay? So factoring will give us an accurate answer, an exact answer every single time, as long as the function can be factored. All right, our third example needs to be set equal to 0. So I'm going to subtract 10. Okay, rule of thumb is that we always try and keep the x squared term positive. So this is 3 terms. It's a trinomial, which means I'm going to have to do magic. Okay, so what multiplies to -10 and adds to 3? 5 and -2. So we group. And go ahead and take out our GCF. Now, if that equals 0 is getting in your way or it's confusing you, you could just bring it down to the bottom, similar to what we do with the GCF, until you're totally done factoring at this step. You could bring it back in when you're ready to split up your factors and set them equal to 0. So my first root is x equals 2. And my second root is -5. So remember, the values that we're finding here is where that function crosses the x-axis. We are finding the roots or the zeros. Okay, pause your video, take a few minutes, and try and solve this one by factoring on your own. So hopefully you remembered to set it equal to 0. Okay, and now this is a trinomial again, and we're going to do magic, but make sure that you remembered to multiply a times c. Okay, so it looks like my values are 10 and -3. Now you definitely have to group this one because it has a leading coefficient. Okay, and it should not matter the order in which you put your middle terms, meaning you could have put the -3 first, and you still would have gotten the same answer. Now remember, all you've done to this point is factor. This is asking you to solve by factor, so there's more to the problem. Make sure that you are completing the entire process. If you were to just leave it as 2x minus 3 and x plus 5 equals 0, you really would not get any credit for that because we already know how to factor and we've already been tested on how to factor. So a big portion of math is understanding what the directions are asking us to do. So I have a root of x equals 3/2, which is 1.5. So that would be a solution, or a situation where the graph is in between two whole numbers. So we probably would have estimated that, and we would have said x is between 1 and 2, and from the graph we would not have been able to tell that the exact solution was 1.5. All right, the last type of example we want to look at is working backwards. So this means that you are provided with the roots and you want to determine what function this came from. Okay, now we're not just going to do a guess and check here. We're actually going to use algebra to solve. So think of the process of solve by factoring in reverse. So The very last thing we did was set the factors equal to 0 and solve. So that's what we have here in red are zeros that have been solved. So we want to go backwards and we want to get these as factors equal to 0. So if we need the right side to be equal to 0, we're going to have to move the roots back to the other side. So we're essentially unsolving this. So I'm creating x minus 3 equals 0 and x plus 5 equals 0. So these were now my factors that I had split up. I'm going to put them back together. Okay, the opposite of factoring and grouping is to FOIL. So I have these two factors here. I'm going to FOIL them together. I'm undoing the grouping, and I'm going to combine like terms. This is the original function that was solved by factoring to get the roots of x equals 3 and x equals negative 5. Now you can check your work by taking that trinomial that we just solved for and trying to solve it by factoring, or maybe even use a different method to check your work and solve by graphing and see if it produces the same roots as x equals 3 and x equals negative 5. Okay, so solve by factoring is definitely an easier method for solving quadratics. We've done extensive work with factoring, so it's really only one additional step to then get the roots. All right, so that is everything for your notes. Please make sure that everything in your notebook is complete. If you have any questions, write those down so that you do not forget by the time we see each other in class again. All right, thank you so much for watching, guys. I will see you next time.